Okay, so now, so what does chance look like? So now you might think that's easy. Maybe it looks like this. All right. So here I have some common depictions of chance from our culture. Okay. So for example, in the United States, chance is often depicted as a woman, and it's usually drawn with some other things that represent games of chance. Like you can see here, there are some suits up here representing the different suits of playing cards. Okay, and so we have chance depicted as a woman. Okay, most of you guys, I'm sure, are familiar with the classic Irish symbols of chance and good fortune. Okay, in Hinduism, it's associated with particular gods, also a woman in this case. The god Lakshmi and Ganesh are usually associated with luck or good fortune and the removal of obstacles. Okay. So I guess we can say that from a cultural perspective, this is how we portray chance. Okay. Um, but mathematically speaking, what does chance look like? And I think many of you already know the answer to this question, or at least have seen it. Okay. Oftentimes, chance looks like this. Okay. If you wanted to take a mugshot of chance, maybe this is what it would look like. This is a normal distribution. It's a standard normal distribution. Okay. Um, now, so chance looks like the bell curve is what I'm saying. Well, it doesn't always look like the bell curve. Okay. There are actually many types of statistical distributions that describe the results of some random process. This is just a very, very common one. Okay. Here are some others. Okay. These are some other distributions. Okay. This here, down here, you'll notice this isn't a typical bell curve. It's kind of like a bell curve that's been shifted over to the left. This is not a normal distribution, but instead what's known as a log normal distribution. Okay. This one up here, this is a Pareto distribution. Okay. And then this one here, this is more like an actual normal distribution, except you can see with real world data, it doesn't look that smooth or that clean. Okay. Okay. So what's the point? So the point is that different types of random processes leave behind different characteristic signatures. And we can learn to read and identify these signatures in order to learn more about the random process in question. Okay? And the tool that we use to do that, what I just showed you, these graphs here, these are known as histograms. They tell you the relative frequency of different things that appear in the data. Okay, and this tool, this histogram, is very useful for understanding where a particular piece of data comes from, or what types of processes drive the creation of a particular piece of data. Okay. Um, and so let me tell you then a little bit more about these histograms. This class is gonna focus on how these histograms are generated and what they look like. So a histogram simply plots the value of a variable on the horizontal axis and the corresponding frequencies associated with those values on the vertical axis. Okay. Okay, so let's have a look at an example of that. Earlier, I asked you to find the fake data in that coin flipping example. Okay. And so let's have a look at one way that we can answer that question by using a histogram. Okay. So I'm going to unhide some columns here. Okay. And yeah, okay. I'm going to unhide some columns. Okay. So you can see what I've revealed here, okay, are some counts. And what I've done is I've gone through and counted the number of consecutive heads or tails. Okay. So for example, you can see that, for example, look at this. This is a group of 3 heads in a row. Okay, 3 heads in a row. And if you look at our entire data set, that happens 3 times. It happens here, it happens here, and it happens here. Okay, and so here you can see consecutive heads, 3 in a row. I've gone ahead and I've recorded that that happened 3 times. Okay, and then I did this for all the other numbers. For example, you can see that here, 1, 2, 3, 4, 5, 6, there was one situation where we got 6 heads in a row. Okay, and so you can see I marked that as happening once. I did the same thing for tails, and then I added up those results. So the total number of consecutive heads or tails here is recorded in this final column. Okay, so I did this for trial A, and I also did this for trial B. I simply counted up the number of consecutive heads or tails. Okay. Now, here's the thing. If you just look at that set of numbers, it's not super duper intuitive, okay, what's going on. And so what I can do is I can take this set of numbers and put it onto a graph, okay? And actually, I hid the graph down here, so let me move it back up. Okay, so this shows us the number of consecutive flips, okay, and how frequently they occur. So for example, there were 28 situations where there was basically just one in a row. So it was heads, and then it was tails, and then it was heads again, that kind of thing. Okay, so that happened, you can see, so this is 28 being plotted here. Okay, there were 14 instances where we got 2 heads or 2 tails in a row. So I'm plotting that here. Okay, it just takes this table and we plot it. Okay, so this thing right here, this thing is a histogram. Okay, it tells you how frequently different outcomes appeared. That's all histogram is. It shows you the frequency of different outcomes. Okay, I did that for this trial as well. Okay, so let me move it over here. Okay, here's the histogram of consecutive flips for this trial. Okay, so now, okay, it's going to be a lot easier to answer this question now that we have these useful histograms. Okay, so let's look at them. Okay, so here's trial B and the associated histogram, and here's trial A and the associated histogram. Okay, trial A, trial B, trial A. What do you notice about those histograms? Hopefully, what you see is that there is a subtle but significant difference in these histograms. Okay, you see, in trial A, there are many more situations where there were a lot of either heads or tails in a row. Do you guys see that? So obviously, it's most common to just get a singleton head or tails. Next most common is 2 in a row, and then the next most common 3 in a row, etc., etc. Okay? But you see, there were quite a few situations where we got 4 in a row, where we got 5 in a row, and there was even a situation where we got 6 heads or tails in a row. In trial B, you can see that it kind of looks like the same histogram, except that it almost looks like that histogram got chopped off, right? In the sense that there are no bars beyond 4. So in this data set, we only ever saw at most 4 heads or 4 tails in a row, and that was uncommon. And even 3 heads and 3 tails in a row was quite uncommon. Okay? So, which one is the real data set? So it turns out the real data set is trial A. Okay? You see, when you flip a coin at random, it's unlikely, but not terribly uncommon, for you to get 4 or 5 or even 6 heads or tails in a row. Okay? Whereas when people are just trying to make up the coin flips, well, especially people who don't have too much experience with probability theory, what they'll do is picture yourself doing it, right? You might say, okay, well, maybe the first 2 flips are heads. And then, okay, well, the 2 heads in a row, okay, so let me go to tails and do a tails. And then maybe it was some heads again, and then, okay, now it's been heads quite a lot, so let me do quite a few tails. So now we got three tails in a row. But, most people who are doing this, they probably wouldn't make like 6 heads in a row, right? That doesn't seem random for there to be 6 heads in a row. So you see, the students who are trying to fake the data, they never had any situations where they had 6 tails or 6 heads in a row. In fact, they never even had any more than 5 in a row of either heads or tails. And that behavior is decidedly non-random. When you have truly random data, it's very possible to get these runs where you see many heads or tails in a row. So then when I looked at this data, actually, when I looked at this data, I could immediately tell which one was the fake and which one was the real, because I knew the real one was more likely to have a large string of consecutive heads like this. Okay. So hopefully that sort of shows you, first of all, it shows you, A, in order to tell the difference between chance and non-chance, you need some knowledge of probability theory. And two, it illustrates the fact that these graphs, called histograms, are quite useful in diagnosing questions like this. Okay? So that's what a histogram is and how we can use it. And I'll see you guys in the next little segment.